Hello, Intro to Chem students. Phase 2 here of our molar conversions is converting from moles to particles. I do want to, because I think I neglected a little bit to say this in the first video, because I'm held to 15 minutes, and sometimes I just have too much to say to get it all done in 15 minutes. So I did want to say, if we are converting, so I did some examples of converting from mass in grams to moles, but of course we can go the other way. We just follow this arrow on the bottom, right? So for example, let me write really. All right, so what if I have moles? So I see I have 6.5 moles of CO2, and I want to know how many grams that is. So I kind of like to always say, hey, what I want to end up with is grams. And I like to write that first. And then I'm starting with 6.5 moles. And I'm going to abbreviate moles, MOL. That's pretty standard abbreviation for moles. And then remember that the thing I want to get rid of is going to go on the bottom of my first conversion factor. If I follow my little line here, to go from moles to grams is going to be the molar mass over 1 mole. So now I have to look up the molar mass of CO2. And again, I find that by looking at the periodic table and just looking at that mass, that atomic mass. If I look up carbon, it's 12.01. So I'm just going to say 12. We can do that. Oxygen is 16. But remember, we're looking at 2 oxygens, so that is, sorry, I'm writing with the mouse, that is 32. So if I add these together, 32 plus 12 is 44. That's 44 grams per mole. So that is where this comes from, 44 grams in 1 mole. So remember that this is a whole number over 1. So what I'm really doing, so 6.5 times 44, it's 286 grams. Now we're going to look at that and say, does that seem reasonable? Could it really be such a big number, 286? Well, yeah, because 1 mole is 44, and I have 6.5 moles. So yeah, it's going to be a pretty big number like that. So that seems reasonable. Okay, so what about if I asked what if I want to know how many molecules are in 6.5 moles of CO2? Now I'm going to follow this path, and I get to use this great big, this is called, remember, Avogadro's number. Let me write that. So Avogadro's number, I want to end up with molecules. So molecules, atoms, or formula units are all types of particles. So I know I want my answer to be in molecules. I'm just going to abbreviate there. Molecules of specifically CO2. What's important here? I want to know, yeah, how many molecules, and I am starting with 6.5 moles of CO2. So I'm going to start with 6, I'm going to go back to blue here. So I have 6.5 moles of CO2. Remember, this is like a whole number, right, over 1, so I remember that that goes on top. I'm going from moles to particles. I want 6.02. So I want 1 mole on the bottom because I want that to cancel out. Okay, so here's a couple of things, and this one would work either way, but here's my piece of advice so that we always know it's going to work. Whenever I have something in scientific notation, when I enter that into my calculator, I should always put that in parentheses. Sometimes it will work without parentheses, but a lot of times it won't. And so to be consistent and know that it's always going to read this as one whole number and not as 6.02 times 10 to the 23rd times 6, you know what I mean? It's just really good practice to always put that in parentheses. So 6.5, and I'm going to calculate this really quickly. So when I punch this into my calculator, it actually, and I have a TI-83, old school, best calculator ever, like does everything and super easy to use. It's a graphing calculator, which always helps because you can see everything that you've entered in. But anyway, it expresses my answer as 3.913, and then there's a capital letter E, and then 24. So 3.913 E24. What that means is 3.913 times 10 to the exponent of 24. So you have to know how to use your calculator. Oops, just kidding. .9 times 10 to the 24th molecules of CO2. Does that seem reasonable? Well, 1 mole would be 10 to the 23rd power. So 6 moles, we would extend that. It makes sense that you would extend that, one more exponent value. And so, yeah, that seems reasonable. That's a lot of molecules, right? And 6.5 moles, we said, we solved that earlier, were quite a few grams. But yeah, this is a huge number. But we're always going to get huge numbers when we're talking about numbers of atoms or molecules. So don't be afraid of that. Okay, so let's solve another one going the other way. How many moles are in a sample of water, H2O, containing 1.57 times 10 to the 28th molecules? So right away, I want to end up with moles because it's saying how many moles. I have water. That might or might not be important. And I'm starting with this many molecules. So 1.57 molecules, and my first step is to get rid of molecules. So I'm following the path of going from moles to particles. Particles to moles. Ooh, other way around. So I'm starting with particles, specifically molecules, and using this conversion factor. 1 mole over 6.02 times 10 to the 23rd, and the particles specifically are molecules this time. So this is going to cancel this is going to cancel out molecules on the top, molecules on the bottom. Remember that this is really a whole number over 1. I said I want to end up with moles. This should get me to moles. And I have to make sure in this one that I put this in parentheses, and then we're going to divide it by this. So 1.57 times 10 to the 28th, I'm going to punch it in my calculator. You should do the same. See if you can solve it faster than I can, or pause this and solve it. All right, so parenthesis 1.57 times 10 to the 28th times 1, so nobody cares about the 1, divided by parenthesis 6.02 times 10 to the 23rd molecules I got a pretty big number here. And this is going to be a big number because this is a huge number of molecules. So hopefully you realize that that seems reasonable, and I think we're good. So good luck on the worksheet. Please always, always email me with any questions that you might have. I'm happy to Zoom with you, or if it means making a second instructional video just to clear up misunderstandings or confusion, I'm happy to do that. Please don't just sit there and be confused and frustrated. Shoot me an email and we'll take care of it. Good luck. Thank you.